Okay, chemistry kids. This is a video lecture on matter, and matter is anything that has mass and takes up space, which you probably remember from middle school or maybe even grade school. And I'm sure you also remember that there are three phases of matter. We have solids, we have liquids, and we have gases. So those are our three phases of matter. If there is another phase, we're not going to talk about it. You're going to need to take physics. Okay. This is a diagram of matter when it changes state. And matter when it changes state requires energy, either energy absorbing or energy being released. So here we have a solid. You can see that the molecules are packed together real tightly and they're touching each other and they're not moving very much, just like the solids that you encounter every day. In the middle you have a liquid. The little circles are more spread apart. They have more movement, they have more energy. And then on the end we have the gases. They're really spread apart, they have lots of energy, and they're moving really quickly. They're bouncing off each other. So what happens when we move from solid, liquid to gas? You probably know those terms, you remember those terms. We're going to use terms you know and some terms that might be new. So first we're going to start with a gas and work our way down. So when you go from a gas to a liquid, that is called condensation. When you go from a liquid to a solid, that is called freezing. So you're absorbing energy. When you go directly from a gas state to a solid state, that's called deposition. And you're skipping the liquid stage altogether. You're going straight there. When we go the opposite way, from a solid to a gas, you have three different changes that occur. From a solid to a liquid is melting, we all know that one. From a liquid to a gas is called vaporization. You probably say boiling, that's fine, they're the same thing, but the chemical term we're going to use is vaporization. And when you go directly from a solid to a gas is called sublimation. Sublimation is not something we see very often. It happens, but we don't see it very often. You see it when you go to the store and you buy dry ice. That is carbon dioxide in a solid form going straight to the gas form, and they use it for theater events to make fog. Okay, whenever a phase change occurs, energy is either absorbed in the form of heat or it's released in the form of heat. So those are the two things that are happening. When it's absorbed, that's called an endothermic reaction. And an example of that is ice packs, or that Alka-Seltzer reaction that we use in the lab. That got cold, that was endothermic. We were absorbing energy, and it was going into our hands and we felt cold. When energy is released in the form of heat, that's called an exothermic reaction, and it gets hot. So when you buy those hot packs for your back or your shoulder and you break them and they get super hot, or the hand warmers, that is an exothermic reaction. Heat is being given off. Now, what we're going to talk about is a heating curve. What do the solid, liquid, and gases mean? How do we use them? We use them, we have to look at a heating curve to show how much energy we need over how much time we need to have that take place. This is a heating curve, it's going up. You could also have a cooling curve that would start at the top and work its way down. Same thing happens. So when you have slope sections, that's only one state. It's a solid state here, it's a liquid state here, and it's a gaseous state here. On the slopes, we have lots of kinetic energy. Kinetic energy is the energy of movement. We're pulling in energy and it's moving real fast. On the plateaus, we have changes. Energy is potential energy, and so it's melting and it's vaporizing. And we have both states. We have a little bit of solid and a little bit of liquid. And you've seen that. What you see when you put your ice cubes in the cup and you fill it with water and then you go away and you return and your ice cubes are half melted, that you are in the melting stage. You still have some ice left, but you also have some liquid there too. And so up here during vaporization and you're boiling your water, you come back to your half boil away pot, you have both liquid and gas in that container. It's not all gaseous vapor at that point as it's starting to boil. So a heating curve is useful when people are manufacturing products in a plant and they need to determine how much energy is required to get something to melt. So it's a graph that gives information to people. And then the other kind of tool that we'll use to help us with phase changes and when phase changes occur is the phase diagram. And every compound has a phase diagram. It's also useful in plants that manufacture products because it tells you when something is a solid, a liquid, or a gas. And it also takes into account pressure. So with temperature you can change the state, but also when you change the pressure you can change the state. So by changing a pressure you can turn something that would normally be a solid into a liquid by increasing its pressure, or something that was a liquid, turn it into a solid. So pressure is measured in atms, temperature is measured in degrees Celsius, which we've talked about. And the phase diagram has 3 sections. It has a solid section all the way over here. In the middle is the liquid section, and then all the way over to the right is the gas section. And it goes like that every single time, solid, liquid, gas. The thing that is going to be different is the size of the liquid section, the size of the solid section, and the size of the gas section. So what are the parts of the phase diagram? You have 2 main parts. You have this section piece down here that's labeled A. A is our triple point. The triple point is the point on the graph where all 3 phases exist in some concentration. So you have a little bit of solid, a little bit of liquid, and a little bit of gas, all right there together at maybe -5 degrees and just below 1 atm on the pressure side. So that is your triple point where all 3 things exist. Then way over here on the other side of the graph is our critical point. The critical point is the point on the graph at which you can't change the pressure anymore and still have it be anything other than a gas. So at the critical point, after that, it will only be in the gaseous state. You can't get it back no matter how much pressure you apply. So what do you use these phase diagrams for? The phase diagrams tell you the melting points and boiling points at different pressures in the world. So normal pressure for our environment is 1 atm, and at 1 atm what you can see is you go over from 1, come to the line, drop it down, and the melting point and the freezing point are 0 degrees C. So that tells us at normal pressure, melting point 0 degrees C for water, which makes sense, we know that. Well, what is normal boiling point for water? We know normal boiling point for water is 100 degrees C at 1 atm. We pull it over, it's at the line, we drop it down 100 degrees C. So what else can it tell us? It can tell us what state something will be in at a specific temperature and pressure. So at 3 atm, 50 degrees C, what state is water in? So 50 degrees C, 3 atm is this point right here, and that is a liquid. So water is going to be a liquid. How can we keep the temperature at 50 degrees, or can we keep the temperature at 50 degrees and get it to turn into a solid? How would we do that? The way you would do that is you keep your temperature at 50 degrees, and then you'd see if you can pull the line anywhere to get it to have your line intersect 50 and the solid section. And we cannot do that. The only time water is solid is when it is in the under 0 degrees C range. So that's the only time we can get water to be a solid. Now, every compound is different, and so because every compound is different, that won't apply to every single one. You have to relook at your graph each time. What happens if we raise the temperature but keep the pressure the same, or lower the temperature but keep the pressure the same. So we keep it at 3 degrees, but we lower it all down to negative 15 degrees C. 3 degrees ATM, negative 15 degrees C, now we're a solid. And so we can change the state by altering the pressure in addition to altering the temperature. So if we keep the pressure the same but raise the temperature up to over 120 degrees, over 100 degrees, then we're now a gas. So you have 3 different things going on here. So, have a great day, chemistry.